Earlier this month, I finally did my first ever mosaic using the new SpaceCat 61 telescope and the ASIair. And I gotta say, this was way more difficult than I ever thought it would be. I was down in Kanab for about 2 weeks, and it took me that entire time just to get 30 minutes of data for 9 panels. This is due to a variety of factors, including the wind, the clouds, and just minor problems on my end. And so I wanted to take all that information I learned on that trip and share it with you guys in this video. In fact, this is actually 2 new videos from my 2024 edition of the Deep Space course. I recently went back and completely redid the course. There's over 80 brand new videos. And so if you want to learn more about astrophotography, really regardless of your skill level, I think you'll learn a lot in this new edition. Without further ado, let's get right into this. We'll start with the ASIair portion of the video, and then we'll move over to the computer and put the mosaic together. The first thing you want to do is go through the standard workflow, which I've shown you in the other ASIair videos. That means step number 1 is to focus the telescope. Step number 2 is to polar align the mount. And then step number 3 is to use the sky atlas and find the target that you want to photograph. That's where we're going to start today's video. So I'll go to the sky atlas button, and then I'll find the target either using the search window, the map, whatever you want to do. And I should note that as of the latest versions of the ASIair firmware, the software does understand common names now, which is a big help. So if I go to the search window and I type in Rho for Rho Ophiuchi, well, it might not find that, but at the very least, you might be able to find Orion, for example. There you go. So this is a big improvement. Anyway, the mosaic that I did was Rho Ophiuchi, and so that's what I'll be going with today, just to show you my process. The IC number is 4603, which is in my current history. I'll click on that. And provided that the target is above the horizon and there's no obstacles in the way, I would click on Go To and find the target. Unfortunately, in my current position, it is not visible, so we're just going to pretend for today's video. But what I would do is hit Go To, tell the mount to go to that specific location, get it centered up roughly, and then at that point, once the target is centered up in the frame, we can back out of the sky atlas. And I actually want you to take another test photo just to be safe. So I'll just take a 3-second long preview test photo. When that completes, I'll click on the Solve button on the left. When it succeeds, I'll click on Sync Mount. This confirms that we're actually seeing the current composition. Then we can go back to the sky atlas and just understand how our composition looks. What I'm getting at here is that we might have to rotate the camera sensor to get a better orientation. And this is something you want to do as soon as possible. So if you're finding that the sensor is off at a weird angle, then you would go over to the telescope. In my case, I'm using the new SpaceCat 61, which I'll have a review out coming soon. But there's a little screw I can loosen, and then that allows me to easily rotate the camera sensor. I can tighten everything down, take another test photo in the preview window, plate solve the image again, sync mount, go back to the sky atlas, and confirm this looks better. This could take you 3 or 4 times to get the rotation where you need it to be. That's okay. Spend the time now and get that figured out. When you're ready, we'll go back to the preview window and change to plan. Then we'll click on the 3 dots and 3 lines. You may already have a plan from earlier. If so, we need to create a new one. For this, I'll click on the 3 dots and 3 lines in the upper right corner. And because this is an example today, I'll create a new plan by clicking on the plus button. Then we start with the name. I'll call this Rho Deep Space Course or something along those lines. If you're following along though, then of course you'd want to name this after whatever target you're photographing. I'd recommend turning on auto guiding, auto meridian flip, and auto cooling. The start time should be set to start now, because if you have it set for some future time, there's a lot of things that can go wrong. And you don't want to waste a whole night not actually capturing data. So your best bet is to start now and then manually trigger it when you're ready to go. The end options are up to you. If you want to turn off the cooler, go to home, shut everything down, whatever you want to do, that's fine. And then we'll hit OK. Next, we'll click on the plus button and then search for the target that we want to photograph. In my case, I'll click on the search window, and I already have the target IC4603, that's Rho Ophiuchi. I'll select that as my target, and then I'll click on the plus button to set my shooting schedule. This is basically what we do in the normal workflows in the auto run menu, but now we're doing it in the plan menu. But it's the same interface. So the exposure, I'm going to do 3-minute long photos. Normally I would do 5, but I'd rather have more exposures even if they're shorter. And because I don't have many clear nights, I'm only going to do 10 photos for each panel. Ideally I would have 20, maybe even 30 photos or more, but there's just no time for it, unfortunately, with the clouds and the wind and the moon and everything else. That's all I'm going to do for right now, is that one shooting sequence. Then I'll back out of this menu. And at this point we have a details and a sky atlas button for that particular panel. I want you to click on Sky Atlas, and you'll note that we have Ro Ophiuchi there, right about in the center. There's Antares at the bottom. It's hard to see because it's not really giving us a full preview very well. Unlike the Orion Nebula, you'd see that very clearly. But what you want to do is click on Mosaic in the upper right corner. This is how we create our mosaic using the Panes X, Panes Y, and overlap percentage. The sliders are a bit tricky, but if you just move your finger off to the right, that will increase them. And so what you're trying to do is find however many panels you need for both the up and down, left and right axis. And you can just use your finger to move the composition around and zoom in to get a nice looking composition. As I mentioned earlier, you may need to rotate your camera's sensor. If so, it's kind of a pain at this point, but you would back out of the Sky Atlas, back out of the plan menu, change from plan to preview, take a test photo, plate solve it, sync them out, go back to the Sky Atlas in the lower left, then you'll take a look at the current composition and see if the sensor is rotated enough or not. If not, repeat those steps until it looks as good as possible. You could even click on Mosaic here and get a rough idea of what that would look like in a few minutes, so don't forget to do that. Anyway, once the current composition looks good and your sensor has been rotated, we'll go back to plan, click on the 3 dots and 3 lines, click on Sky Atlas, and let's try that again. My mosaic of Ro Ophiuchi was 9 panels with a 15% overlap, and I found that the 15% overlap was plenty. If I would have done any more than that, I wouldn't have had enough area in my mosaic, because as you can see, the more overlap you have, the smaller the mosaic becomes. So I think 15% is a good middle point for that feature. And I just want to reiterate that when you're trying to figure out your panels for your X and Y axis, obviously you just have to get it so the composition looks good, but you have to keep in mind how long this is going to take to gather that data. I'm only doing 30 minutes for each panel, and it's still going to take me over 4 hours to get that data. But once the composition looks good and you're ready to commit to that mosaic that you see, then click on the plan button in the lower right. That will commit the current mosaic to the plan. And it's now reflected there at the bottom. Then we'll back out of the Sky Atlas, and we have that initial plan, which says, in my case, IC4603. That was kind of just temporary to get things up and running, so I'm going to delete that. This gives us the official mosaic. We've got _11, 12, 13. Then we have the next row, 21, 22, 23, and then 31, 32, 33. From here, we have to click on details for each one of these panels and confirm that the settings are dialed in. And unfortunately, as far as I'm aware, we have to do this manually for each one. There's no way to copy them over. I mean, there might be, but I haven't found it. So I'll start with the first panel. I'm doing 10 exposures, each 3 minutes long. Then I'll back out of that, and I'll do the same thing for the rest of the panels. So details, 3 minutes, repeat for 10, 3 minutes, repeat for 10. You get the idea. Make sure you've done that for all of your various panels. Next, we need to turn on the check marks for each panel to confirm that they'll actually be part of our sequence. So I'll turn on the little check mark for all 9 panels, and this tells me that it's going to take about 4 hours to complete, and it'll take about 4 gigabytes to capture all that data. At this point, we should be ready to go. Let's back out of the planning menu, and we can now click on the circle button to begin the mosaic. And so what it will do is it'll go to that current composition, it will automatically start the guiding, it will turn on your cooler if that needs to be done, and then once the guiding looks good and it's done the calibration, it will begin the shooting sequence. At that point, it's going to run through until it's taken all of your photos, and then it'll be finished. With any luck at all, it should be that simple. However, when I was doing my mosaic down in Kanab, I had all kinds of problems. Some nights the clouds would roll in, other nights it would get really windy out of nowhere, and then some nights I just forgot important camera gear. Point being, I never got through the full mosaic in one night. It actually took me upwards of a week to capture all the data. If this happens to you, and you need to restart the mosaic on another night, let me show you some tips. So let's say it's night 2, and you've gotten through 2 panels, and everything else was kind of a waste. If this is night 2, we'll go back to the plan menu, click on the 3 dots and 3 lines, and assuming you got through the first 2 panels, well, we could just move those to the end, and that way we can start right off on the 3rd panel. So for this, I'll click on the first panel, and now I can move it backwards. I'll just put all the way at the back of the list. Then I'll click on the 2nd panel and also move that to the back of the list. Now we just have panel 1, 3, that's our starting point, and that allows us to pick up where we left off. In addition to that, maybe you already have 5 photos from panel number 3, and you don't need to take 10 extra ones. What you can do is just edit the details, and if I already have 5 out of 10, I'll change the number of photos to just 5. Then I can go back to the plan interface and restart the plan right where I left off. The final bit of advice is if we go into the internal storage and click on Image Management, you'll find your photos under the Plan folder. And this can be very helpful if it's been a few days since your last shooting, because you might forget what panel you were even on. But if I come in here, I might be able to see that I only have 10 photos for the first panel, and the rest I only have 1 or 2 photos or something like that. So it's just another way to remember where you're at in the shooting sequence. And speaking of this, if you are going to be copying these photos to your computer, then you'd want to get them from the Plan folder, not the auto run, which is normally where we get the data from. But that's all I've got for you in today's video. I've shown you the full process for creating Mosaic, along with some important troubleshooting tips. Hey everybody, in this video, I'm going to show you how to create a mosaic using PixInsight. And I want to warn you right here at the start of the video that this is a lengthy process, and it might take you all day to create a final image like you see here. This is a 9-panel mosaic of Rho Ophiuchi taken with the SpaceCat 61 telescope. And we'll get into all the details as we go through the full video. I should mention that ideally this would have been a 12-panel mosaic, if not even larger, but I just didn't have the time to pull that off. As I mentioned before, we are going to be doing this full workflow in PixInsight, including the stacking. I realize that the stacking takes a lot longer than other programs, but today it's the best choice. Step number 1 is to create your cosmetic correction. We can do this from the Process Explorer, and I've shown this in the stacking videos. With cosmetic correction, we'll turn on Use Auto Detect and Hot Sigma. This should fix any hot pixels in your photo. And we'll rename it to CC just to make it easier to find later on. Step number 2 is to run blink or inspect your photos however you wish. We just want to confirm that they're actually sharp. And this actually brings us right into the file organization, which is critical to your success. All of these photos were captured with the ASIair, as I showed in another video, and these are the folders that it came up with on its own. We have 3 columns and 3 rows. So we have 1, 2, 3, 2, 2, 3, and then 3, 2, 3, if that makes sense. I hope that your photos are this organized, because if not, you're going to run into all kinds of problems. But right now we'll start off in the first folder, select all the fits files. Unfortunately, I only had 30 minutes worth of data for each panel, which is not a lot. Then we'll inspect each image looking for any potential problems, including clouds, blurry stars, and whatever else might have interfered. These all look fine, although I will say there are some high-level clouds, but that's the best I can do. If I notice that some of the photos are blurry or didn't look very good, I can delete them and remove them from the stack. You'll need to repeat this process for all of your panels, because I don't want you including any bad photos throughout the rest of the workflow. When you've confirmed that each set of photos looks good, that was step number 2. Step number 3 is to stack the photos together. We will be using weighted batch preprocessing for this workflow. I want to stress one more time that you need to stack in PixInsight for this workflow. If you use any other stacking application, I cannot guarantee that things will work properly as we go later on in the video. You'll want to start by clearing out anything that you might have Then we can load in our new files. I'm going to start with the very first panel, select all of my light frames. Unfortunately, I only had 10 3-minute long photos, which means my stacking isn't going to be as good as I would like. Ideally, I would have at least 15 or 16 photos, or hopefully even more than that. I did not take any flats, darks, or bias, so no need to worry about those, but if you did, you'll want to include them as well, especially the flats, because if you have a weird vignette in each stack of photos, that's going to make things harder as we go forward as well. But as you'll see today, even though I didn't take flat frames, my final image still looks nice. When all your photos have been loaded in, we'll come back to the Lights tab, go to Astrometric Solution, and then click on Image Solver Parameters. We need to copy over the right ascension, declination, focal length, and pixel size for this set of photos down over here. That means my right ascension would be 16, 38, 16. Declination would be 27, 27, 53. And because there's a minus sign, that means the S is turned on. The date and time, just do something fairly close. It doesn't matter that much. Mine was taken in May in Kanab, Utah. The focal length is different than normal for me because I'm using the new SpaceCat 61 telescope, which did a really nice job. So I'm going to put 298 for this particular image, 3.76 for the pixel size, and then I can click on the red X to get out of here. Another important thing to turn on is auto crop, because when we create our mosaic, we don't want any crap around the edges. Therefore, auto crop will help us later on in the workflow. The output directory, well, for this, you need to stay organized, as I've stressed so far. So I'm going to put this in my first folder. I'll create a new folder called PixStack, and inside of here, it's going to auto-generate all the folders that it needs. So if you're following along, just create a new PixStack folder, make this your destination, and that's all you have to do. Then we'll go to the Calibration tab, click on the header for our light frames, and choose CC for the cosmetic correction. That's what we created at the start of the video for step number 1. It's back here somewhere. And we'll apply this to all of our light frames. That should fix the hot pixels. If you captured your darks and flats and whatever else, you'd want to verify that they are calibrating properly. Then inside the post-calibration tab, just take a look at how much data you captured. Mine was only 30 minutes, not great, but it's the best I can do. Finally, we'll click on Run. It'll give us the usual warning messages, that's fine. And once we hit continue, this will take anywhere from 30 minutes to a couple hours, depending on how many photos that you captured. Once that is complete, you just hit OK, whatever it says, and it should bring you right back into WBPP. We need to repeat all these same steps for each of the panels that we captured. Therefore, to go back to my Lights tab, clear out the photos, then I'm going to add in my next panel, which would be 1, 2. I'll select my light frames. Your flats and darks should still work from the previous set, so that should be fine. Make sure you change the astrometric solution though, because your coordinates have changed and those need to be updated. Mine would change to 16, 37, 14. Declination would be 23, 37, 59. The rest is probably fine for this one. Don't forget to also change your output directory. Otherwise, it's going to overwrite potentially what you've just done. So we'll create a new PixStack folder in the second panel. This will now be our new main directory. Everything else should be fine, but it's a good idea to go to the Calibration tab. Confirm that you are still doing the cosmetic correction and apply it. Then you'll run this set of images. So it'll be another 30 minutes to a couple hours. When that's finished, you go through and do it again. You get the idea. Once you have a final stacked image for all of your different panels, we can move on. And I'd recommend that you come into your different PixStack folders and you'll see like a calibrated, cosmetized, debayered, whatever. Those folders are just going to take up space, and it's going to take up a lot of space if you have a lot of panels. For this reason, I want you to delete all of the folders except for the master and potentially the logs. You don't really need logs, but it doesn't take up any space. Inside of the master folder, the main thing that we're looking for is the autocrop.exisf. This is essentially our master file. And if we open it up, at least for the first panel, take a look and see how it is. The first image is our auto crop mask, which shows me that the dither really didn't do much at all, which is actually probably a good thing, because if you have a lot of dither, there's a chance that your overlap you set in the ASIAir will not work as well as you would have liked. Anyway, don't worry about that. We'll look at our other photo. And as you might expect, at least with a color camera, it's very green. Which brings me to one thing I want to stress. If you're trying to do this mosaic with a monochrome camera, good luck. You're going to need at least 2 sets of images like H-alpha and oxygen, or even 3 or 4 sets of images if you're doing RGB and luminance, whatever. That's going to be just really not a lot of fun to deal with because there's so many files you have to contend with. And it'll probably take you months to get all the data that you need if you only get a few clear hours per night. So to make your life simpler, if you have a color camera, use that for any mosaic. It's really going to streamline the entire process. But with this color photo, the reason I'm showing you it is because most likely every single one of your color images is going to have that green color cast. Depending on who you talk to, some people will say you should wait until the end of the mosaic to fix this color cast, because why not just fix all the color casts at once? That could work in theory and I don't have a problem with it, but my thought process was a bit different. When I go to create the final mosaic, I want all the data looking as good as possible. Then it should stitch together perfectly, and I'm already almost done with the workflow. So that's the mindset that I took creating my mosaic. Just understand that not everybody's going to agree with that idea. But what I'd recommend you do is start by running SPCC. This will fix the color cast in all of your different panels. I did not use any filters, and this was a standard ZWO camera, so the default settings are fine. I'll apply this to all of my panels. When that completes, we can auto stretch the photo again to see the color corrected variant. This also brings up some other problems, including vignette, which we'll talk about in a minute. But in order to stay organized, you probably just want to do one panel at a time. Don't bring in all 9 or 12 or however many panels you have, just focus on one thing at a time. So we'll just start with the very first frame for right now. My first step was to fix the color cast, which I've done. My second step is to fix any star distortion with Blur Exterminator. Because if you have deformed stars in the corners, that's going to make it harder to stitch together. We might as well fix that as well. But because I'm using the SpaceCat 61, there's really not much star distortion to worry about, which is a nice thing. Either way though, it's a good idea to run correct only on your photo with Blur Exterminator. And that does look better. Even though the star performance was fine before, it is noticeably sharper now, thanks to Russell Croman. I'm not going to run Blur Exterminator with the sharpen adjustments though. I'd rather save that until we have our final mosaic. So we're just going to do correct only for now. Another thing you might want to do to inspect the overall gradients and vignette in your photo is run Star Exterminator, because when you run Star Exterminator, that gets the stars out of the way and makes it easier to see what's going on. Feel free to just minimize that stars photo and get it out of the way, and then take a look at your background photo. I will say that there is a bit of a vignette in the corner. Well, it's not really noticeable, but on the one side it's dark blue, on the other side it's a bit green. I am photographing Ro Ophiuchi though, which is a very dynamic area. And the point I'm trying to make is that perhaps once you've removed the stars, you see a noticeable vignette affecting the entire photo. If so, you might want to fix it now before creating the mosaic. This is another area where people have varying opinions. Some would argue that you're better off waiting until after the mosaic to fix any sort of gradients or vignette, but I would argue the opposite. Because if you have noticeable problems in each frame, they're just going to be multiplied in the final image. So it would be better, in my opinion, to fix all this stuff now before we merge things together. As you know, there's 2 different ways to fix your gradient. The first is dynamic background extraction, which I've shown you. The second is gradient correction. Use whatever one you're more comfortable with. And again, this should only be necessary if you have a noticeable gradient or vignette throughout your photo. I don't think it's going to be a problem today. In fact, I know it's not going to be a problem, so I'm not going to worry about it personally. I just want you to understand that if you did, this might be a good idea. So if things look good, you can always just undo the Star Exterminator to bring the stars back. And that's all we have to do for each panel. Fix the color cast, run Blur Exterminator correct only, and potentially fix the gradients and the vignette if you have them. Just as a side note, if you did run gradient correction and you fix the gradient and you want to get your stars back, what you would do is rename your photos. I would just call this like row 1. And I'd rename my stars to stars. Then I can use the pixel math tool to just add them together. That's all there is to it for the equation. It's pretty simple when the photos are still in the linear state. Then if I click on the square, it looks like it went to the stars image. That's where they're combined again into. You could always just tell it to create a new image. That would also work. Either way, once you fix the color cast, the blurry stars, and potentially a gradients and vignette, we can now save this as our master file. With File, Save As, and if you haven't done so already, I want you to create a master folder inside of your panorama folder. So I've got all my different panels. Now I have a new master folder. And inside of here, I would create an exisf. You can already see what my naming scheme was. Row_1, 1. The name has to be precise so you don't get confused later on. And this needs to be an exisf. That way it retains all the valuable metadata that we need. Okay, that completes the first panel. We have to do this same step as many panels as you have. So you might want to close out of everything just to stay organized. Then go to File, Open. Go to your second panel. Inside the master folder, grab the auto crop and repeat those steps. Again, SPCC, blur exterminator correct only, and then optionally, you can fix the gradients and vignette with whatever tool that you prefer. When that's complete, you would save this as an exisf file as well. Inside your main master folder, this would be panel number 2. Repeat that as many times as you need. Like I said, this is going to take a long time to create a mosaic, so hang in there. When all of your panels have had some basic adjustments applied, we can now try to create the mosaic. The first step in this is to grab the MosaicByCoordinates script. The easiest way to find that is just type in Mosaic up top in your Process Explorer. And what MosaicByCoordinates does is if we start by loading in our files, we'll click on Add Files, navigate to the master directory, and I'm going to grab all of my different panels that we ran SPCC and Blur Exterminator on. You shouldn't have to do anything else. The only thing would be the output file suffix. You might want to put underscore, whatever you want to do. It really doesn't matter. This will just differentiate the new files that it creates from the old ones. But the default settings should be fine. I don't even think you have to specify an output directory because when I did, it didn't seem to work properly. When you've loaded in all of your different panels that have been corrected, you've added an output file suffix, you can hit OK. It will now go through and do what it needs to do. It might take upwards of 10 minutes or so. When that completes, we can close out of whatever tool might be open. And now we'll inspect those new photos. They should be in the master folder alongside your originals. Mine are designated by _RA. Let me open up the first one and show you what it did. If I hit Control or Command A, check that out. It created a giant canvas and then placed their first photo in the lower right. If I grab the second image with _RA, now we have an image in the center. And if we compare these side by side, you can see we go from the left panel to the right panel. There is a bit of an overlap as we specified in the ASIAir. For me, that was about 15%, which seems to be plenty. Then I can open up panel number 3. This shows us that we've got the full bottom row. And then the second row would be the numbers 2, 1, 2, 3, and then 3, 1, 2, 3. That would fill in this entire canvas. So that's what you need to have. And one thing that can help is using the function that's called like blink here in PixInsight. The way this works is if you line your photos up in the exact same spot, and then you click on the file header, as long as you click and hold, it'll show you the two photos, the one on top and the one below it at the same time. This can allow you to see the overlap between two photos, which is helpful for this mosaic feature. Again, you line up your windows, you click and hold on the file name, and that shows you the image below it. We're just doing this to confirm that the MosaicByCoordinates found all of our photos and placed them logically in the canvas. I know this has been a long video and it took you even longer just to do the stuff on your own, but we're now ready to create the mosaic. There's two different ways to do this. The first way, which I don't recommend, but you might as well try it, is called GradientMergeMosaic. Again, if you type in mosaic in your Process Explorer, it'll be probably the first option. I don't know why they called it gradient merge. I mean, it says right here, but to me that kind of sounds confusing, but that's the tool that we're looking for, Gradient Merge Mosaic. What you want to do with Gradient Merge Mosaic is load in your new files that have the _RA or whatever suffix you chose during the MosaicByCoordinates step. You do not want to use the original master files because those will not work as intended. I have now loaded in the files that we see here, and then we have to choose the parameters, either average or overlay. If you click on the document icon, this will bring up all the documentation for the tool, which could be very helpful if you understand all the advanced things that they're trying to tell you. For example, the first consideration we have is either overlay or average. I would argue that average might give us better results, because this can improve the signal to noise ratio on overlapping regions, which should be as much as 15% per overlap. And the nice thing is, if you're not sure, you can always just try running both and see what looks better. More importantly though, you have to decide on the shrink radius and the feather radius for this tool. That's where you're going to run into more problems. And this is something that I saw when I ran Gradient Merge Mosaic. I had these weird effects around bright stars near the corners of my images. And it seems that no matter what I adjusted the shrink radius and the feather radius to, this problem persisted. That's one reason I'm not a fan of this approach, as I said right at the start. Therefore, I'd recommend you do your own research on which feather radius and which shrink radius to use for your photos. Because I've not used this tool very much, I don't have that much valuable insight, unfortunately, and there's plenty of much more knowledgeable people online that will have some tips for you. Just understand that these are two things that you want to adjust to get better results. You might also want to turn on Generate Mask just to see what it's doing. Before we continue on, I want to stress that I do not recommend doing it this way, but it is the easiest approach and the fastest. When you've loaded in your files, you've specified either average or overlay, you've adjusted the shrink radius, feather radius, etc., we can now click on the circle to begin the mosaic process. This will take a while. So I'm going to let this run and I'll pick back up with you guys when it completes. Okay, we're back. You might want to check the time on the lower right to see how long that took, but I am using one of the most powerful computers you can buy, so keep that in mind. This is a look at our mask, which shows the overlap nicely. It looks fine. And this is our new mosaic image. If I hit Control or Command A, let's take a look and see how it turned out. Well, I see one problem. I forgot one of the panels. I have 1, 2, 3. I forgot 2, 1. So that explains why we're missing a gap there. That's irrelevant though, because the main concern I have with Gradient Merge Mosaic is the weird star pattern that I noted earlier. As we saw in the documentation, this is related to the feather radius, which I could probably get figured out, but I've tried a few different times and I said, you know what, there's a better way to do it anyway, I'm not going to bother. That was my main problem with it. The other problem I had was the stitching that was visible in the background, which could also probably be reduced by adjusting these settings, but no matter what I did, it didn't seem to help. The best way to see the stitching problems is if we run Star Exterminator on the photo. With Star Exterminator finished, you can hopefully see the stitching a bit better, and there's a clear line right here through the photo. There's also another one here. That's why I'm not a fan of this approach, due to the star performance and the obvious stitching, which theoretically could be fixed, but as I said, I was having trouble figuring that out. Alright, now that I've shown you Gradient Merge Mosaic, and you've seen how fast and easy it could be, assuming you get your settings figured out, let me show you another approach that's much more involved, but should give much better results without fiddling with these settings. You will need to download an optional repository for this script, so we'll go to Resources, Updates, Manage Repositories. The repository that you need is PixInsight.astroprocessing.com. This will be linked down below and also in the PDF, so you can just copy and paste it in if you need to. Once you've added in this repository, don't forget to check for updates, and then it will prompt you to install it. At that point, you need to restart PixInsight, and then you can follow along with us in the video. With the repository installed, you should now be able to find Photometric Mosaic. That's basically what we installed. There's a lot of good info written out for this tool if you turn on the documentation browser. I know that this looks scary and there's so much to worry about, but as you'll see, we only have to adjust like 2 or 3 things, so it's actually pretty easy to do. Let's start at the top. It says number 1, use normalized scale gradient during pre-processing. We haven't done that, but I think we'll be okay. Number 2, read the quick start guide, which we could do by clicking on help. You might want to do that, but at the same time, don't get overwhelmed and confused because there's really not much here. Step number 3, use script MosaicByCoordinates. We've done that. Step number 4 is to use the trim mosaic tile. However, because we turned on auto crop, we shouldn't need to do this step because any junk should have gotten cropped out already. Feel free to give it a try though. If you want to be as thorough as possible, I'm not going to bother. Step number 5, join linear images into either rows or columns, and then join these strips to create the final mosaic. That's where things get cumbersome, especially if you have a large mosaic with 9+ panels like I do. Let's start off with the reference view. I like to think of this as our baseline image, if you will. You will need to have your photos loaded up when you do this, so let's actually close out of this and open them up. I'm going to start with the first row, which would be the first 3 photos, with the _RA. Okay, I've got my 3 images loaded in to start off with. We've got the first panel, the second panel, and then the third panel for the bottom row. Because I have 3 panels at the bottom of my mosaic, that makes things more difficult. If you only had like 2 frames, this would be way easier. But what I need to do is choose the photo that's in the middle. In this case, 1_2. Then I'll go back to Photometric Mosaic. This is going to be my reference view, image 1, 2. And if I hover over it, it shows me that that's the photo I want to use. The target view, you can use either one, because we have to do this in multiple steps. I'll just start with image 1, 1. I realize this is confusing, so let me explain what we're doing. We're going to merge these 2 together, the middle panel and then the lower right panel. We have to do this like 6 or 7 different times though to get the entire mosaic complete. That's why I said this is very cumbersome. And while the GradientMergeMosaic didn't work that well, at least we have to deal with all this extra crap. With all that said, I've got my first 2 panels selected that I want to merge together. The image scale, it looks like it auto-detected this stuff, but it's not correct. So I should click on image scale. My pixel size is 3.76. The focal length was about 300. You have to update this every single time, which is another problem with this tool. It's a bit of a pain. Everything else can be left to the default. Then we'll click on Run. It gives us a warning that we have not run Trim Mosaic Tile, but I'm not worried about it. I'm just going to hit Ignore, and we'll see what happens. There we go. There is our first merge of the day. We have the lower middle and the lower right joined together. There is a slight red line which shows us the boundaries of the overlap, and this is reflected with the mosaic mask in the upper left. This is mainly just for troubleshooting purposes and to confirm that there's no seam. If things look good, then just close out of the mask and don't worry about it. Okay, that was our first merge. Let's do that again. We'll go right back to Photometric Mosaic. Now I can grab the new file that we created, which was Mosaic, which you might want to even rename to stay organized. And we're going to merge that with the other panel, which would be in the lower left. That should create the bottom row. Don't forget to change the image scale to whatever it is for your camera. If you're not sure, just Google the camera sensor. That will show you the pixel size. But we did that during the stacking anyway, so you should remember. That's all there is to it. We'll click on Run for the second time. We'll ignore the fact that we didn't trim anything. Then we'll close out of Photometric Mosaic. Close out of the mask unless you want to inspect things up close. That's probably not a bad idea. Confirm it looks good. And check it out, we already have our bottom panel done. We need to repeat that for the next 2 rows. Therefore, I'm going to close out of the original mosaic. We don't really need that one anymore technically. We'll just have this one somewhere in the background. We might want to call it bottom row and minimize it. Then I'll close out of the 3 photos because we don't need these either. Let's repeat these steps for the next 2 rows. So I'll go to File, Open, grab 2.1, 2.2, 2.3. These are all the _RA, which had the mosaic by coordinates applied to them. We can auto stretch all 3 photos to make it easier to see. And we'll repeat the same steps. Photometric Mosaic. Start with the middle photo, that's your reference view, which for me is 2.2. The target view, you can either do the right side or the left side, it doesn't really matter. I'll do the right side. Don't forget to change the image scale, 3.76 by 300. And then you'll go through and run this one. This is all working perfectly for me, but there's a chance that you will encounter problems, which is why I stress that you want to stack everything in WBPP and follow along with me exactly today, which should ensure that you don't have any problems whatsoever. But there's our second row. We'll go back to Photometric Mosaic. All right, our new reference view is going to be Mosaic. Then we'll do the left side. This will finish up the second row. Don't forget to change the image scale. I'm just going to do the rest of this on my own because you've seen what to do. I don't want to waste your time. This has gone on long enough already. When it's complete, I'm going to show you how to put all the pieces together. At this point, I have the bottom row, the middle row, and the top row completed. We can finally put the mosaic together. Same exact process, Photometric Mosaic. I'm going to start with the middle row as the reference view, and then for the target view, I'll probably do the bottom. Don't forget to change the image scale again. Then we'll run this one. Finally, we'll take this new mosaic, which should be the bottom and the middle, and we'll add in the top row. That will conclude the process. We just got to remember to change the image scale for the 100th time. After all of our hard work, we are finally done with the mosaic, at least initially. We've merged everything together, and that looks great. I'm just going to close out of things to free up some processing power on my computer, which is important to understand that if you're working with a high-resolution camera, this is going to really strain your computer. I mean, I have a 4090 GPU, which, if you know anything about GPUs, that's their latest and greatest from NVIDIA. I've got a 13900K CPU, 32 gigs of RAM. This computer is about as good as you can get as of early 2024. And still, it's struggling to run this huge mosaic. So I can only imagine how much trouble my laptop or my other computer would have trying to do the same process. That's another reason why I don't want you guys using very high resolution cameras that are above like 30 megapixels, because anything like this is going to become nearly impossible unless you have the best computer available. Either way, we have completed the initial part of the mosaic process. Look things over. If you see any problems, now's the time to fix them. We do have some borders which will crop out towards the end. I'm not worried about that. I'm actually going to start off with Blur Exterminator because we want to sharpen up the details, which we haven't done yet. So we'll turn off Correct Only. Sharpen Non-Stellar, I'll put to around 0.8. Sharpen Stars, maybe like 0.3. And then I'll run this on the entire photo. It might take a while. I should mention that if you haven't run SPCC yet and you're waiting until now to do it, run SPCC before Blur Exterminator, because this can throw off the algorithms if this is run on the photo. SPCC might not understand the stars after Blur Exterminator. Really, this would be the same workflow at this point as you're used to throughout the Deep Space course. As you know, you'd run SPCC, Blur Exterminator, Star Exterminator, fix your gradients, Noise Exterminator, and so on. It's really not doing much for me today because the data was so sharp to begin with, so that's actually a good sign. Next, we'll run Star Exterminator, and we'll generate a star image. That way we can set up the image for further processing It would make it easier to do any sort of gradient correction, and we can confirm that there's no seams. But in my experience, if you use the Photometric Mosaic, then there's no seams to worry about compared to the GradientMergeMosaic, which I showed you earlier. I will not be getting into the rest of the artistic processing today just because we've got so many other videos on in the Deep Space course, and it's going to be different depending on what you photographed and what filters you used. Therefore, I want you to just go through and do our normal process as we discussed. At this point, if you had gradients or vignette, you would want to fix them with whatever tool you prefer. This looks good to me though, because this is actually red down here. There's a lot of H alpha. There's not much in the upper left though. That would be towards your dark space, so that makes sense that it's a darker blue. I could run Noise Exterminator though, because I only had about 30 minutes of data per panel, which is almost nothing. And ideally I would have a couple hours per panel, but it's just not going to happen. But I'd go through, I'd run Noise Exterminator, I would stretch this photo, then I would take it into Photoshop for the rest of the artistic processing, which I've shown you in all the other videos. The only other thing I want to mention is file sizes, because this is something that really was a hindrance throughout the workflow. If I were to save this as an XISF file, and that's what I'd recommend because this will retain all the image data that we need for PixInsight. So I'll save this as Mosaic Deep Space Course, XISF. We'll do 32 bits, and let's see just how large the file size is. It's currently 2.19 gigabytes. That's fairly large for an image. And the problem I was running into is when I was running this in Photoshop and doing all my edits, I had multiple layers. The file size of the TIFF got almost up to 4 gigabytes. As you see there, 3.56. And in fact, on my final image, it was so large that the final image was 7.2 gigs. That was a problem because a TIFF can only be a max of 4 gigabytes. Therefore, I had to use Photoshop's proprietary PSB file format. This will prompt you if it needs to do it. It'll say, hey, I can't save a TIFF. This file is way too big. And it will force you basically to save a PSB. That's fine. And let me just close out of things so I don't crash the computer. But the PSB is essentially a TIFF. It's lossless. It has all the layers intact and allows you to have that large file size if you need it. I hope my audio isn't cutting out right now, but like I said, this is a very powerful computer and it is struggling to even open up the file. That's why I've been kind of warning you guys throughout the whole video that you need to have a good computer if you want to do these large mosaics. And frankly, the amount of time and effort I spent to create this single photo was probably not worth it. Mosaics are fun to do maybe once a year, but beyond that, this is just not the way you want to be doing astrophotography. It's so much extra work. But you can see I've got all my different curves and vibrance layers, which you're accustomed to. I did some cleanup to fix the planes and satellites, some selective color, and a few camera raw filters, which I should have named, but I got lazy. Then once I have my photo looking halfway decent, I would save this as a 16-bit flattened TIFF file. I could bring that into PixInsight, blend the stars back in, and then once I have the stars blended back in, I would crop the image. So let's just pretend the stars are in here. I would use the crop tool, and then finally at the end of the workflow, I can get rid of the edging. I don't want to do it any sooner than the end just because it can mess with the astrometric solution, and that's the last thing we need. But anyway, you just crop in your photo, assuming that this is your final version with the stars intact. That's when you want to crop it. And then you're ready to save your final JPEG, so feel free to do that at your convenience. And that's all I've got for you in today's video. I've shown you more or less the full process for creating a mosaic using PixInsight and the Photometric Mosaic script. I hope you enjoyed the video and you learned just how difficult mosaics can be. That was my main takeaway. And if you've been struggling, I hope this gives you the info that you need to be able to pull this off. So thanks for watching, and I'll see you guys in another video.